Here we have a problem on arithmetic progression. Okay, let's go the information. If 10th and 11th terms of an arithmetic progression are roots of equation 3x square into px positive q equals to 0, and common difference of the arithmetic progression is 3 over 2. Also, the sum of first 11 terms of the arithmetic progression is 88. Then q negative 2p is. Okay, using the given information, we have to find the value of the expression that is q negative 2p. For that, we need the value of the constant q and p. Okay, now let me take the information over here. There is a sum of first 11 terms of the arithmetic progression is 88. Let me write the stuff over here. S11 equals to 88. S11 is a sum of first 11 terms. Okay, in an arithmetic progression, there is a formula to get the sum of first n terms. That is Sn equals to n over 2 times a1 positive n negative 1 times d. This is a formula to get sum of first n terms of an arithmetic progression. Here this a1 represents the first term of the arithmetic progression and this d represents the common difference. Okay, now to get the expression which is equivalent to S11, what I have this I have to plug in n equals to 11 over here. Okay, now I am going to plug in n equals to 11 into this expression that can be used for S11 over here. Then I am getting 11 over 2 times a1 positive n negative 1 means 11 negative 1 times. Here I said that d is a common difference. We know the value of d. There is a common difference of the arithmetic progression is given in the question. That is 3 over 2. We can plug in 3 over 2 for d over here equals to 88. Okay, now we have only one unknown in this equation, that is a1. So to solve for a1, what I have to do is I have to isolate a1. For that, I have to get rid of all the values around the variable a1. Okay, for that, first I'm going to get rid of this fraction 11 over 2, which is multiplied over here. To get rid of this fraction 11 over 2, what I have to do is I have to multiply both sides of this equation by the reciprocal of this fraction, that is 2 over 11. Okay, let me multiply on the right side also by 2 over 11. So here this 2 will cancel out, this 11 will cancel out. I'm getting 2 times a1 positive 11 negative 1 is just 10 times 3 over 2, which is equal to 11 goes into 11 1 times, 11 goes into 88 8 times, then 8 times 2 is 16. Okay, here 2 goes into 2 1 times, 2 goes into 10 5 times, then I'm getting 2 times a1 positive 5 times 3 is 15 equals to 16. Okay, now let me subtract 15 from both sides. When I do so, this positive 15 negative 15 will cancel out. I am getting 2a1 equals to when I combine 16 and negative 15, I'm just getting 1. Let me divide both sides by 2, then this 2 will cancel out. I am getting a1 equals to 1 over 2. Okay, now I got the first term of the given arithmetic progression, that is 1 over 2. Using the first term 1 over 2 and the common difference over 2, I'll be able to get the value of the 10th term and 11th term of the given arithmetic progression, so that I can use other information over here and I'll be able to get the values of the constants p and q, and I can get the value of this expression. Okay, for that, let me consider the nth term or the general term of an arithmetic progression, that is an is equal to, an equals to a1 positive n negative 1 times d. Okay, using the nth term of the arithmetic progression formula, we can write the expression which is equivalent to the 10th term, that is a10. For that, we have to plug in n equals to 10 over here in this formula. Then I'm getting a1 positive. When I plug in n equals to 10 over here, 10 negative 1 is 9 d. Okay, now to get the value of the 10th term of the arithmetic progression, I have to plug in the value of a1 and also I have to plug in the value of d over here. Just now we got the value of a1, the first term, which is 1 over 2. I can plug in 1 over 2 for a1. 9 times the value of d, the common difference is 3 over 2. So let me plug in 3 over 2 for d. Then I'm getting 1 over 2 positive. 9 times 3 is 27 over 2. Okay, here we have the common denominator 2. So we can take the denominator 2 in common and we can add the numerators 1 positive 27. Then I'm getting 28 over 2, which is equal to 14. Okay, now I got the value of the 10th term, that is 14. In the same way, we can get the value of the 11th term, that is a11 equals to the same thing. We have to plug in n equals to 11 over here. Then I'm getting a1 positive. When I plug in n equals to 11 over here, 11 negative 1 is 10d. Now I can plug in the value of a1, the first term, 1 over 2 positive. 10 times the value of d, which is 3 over 2. Then I'm getting 1 over 2 positive. 10 times is 30 over 2 equals to. So now what we can do is we can take the 2 as common denominator. Then I'm getting 1 positive 30 in numerator. Then I'm getting 31 over 2 as the value of the 11th term. Okay, now I got the value of the 10th term 14 and the value of the 11th term, that is 31 over 2. Now we can use the values of the 10th and 11th terms over here in this information and get the values of the constants P and Q. Okay, now let me erase the stuff for what I've done so far and continue the problem. Okay, now let's continue. Okay, now let me consider the information over here. That is 10th and 11th terms of the arithmetic progression are the roots of the equation 3x square negative px positive q equals to 0. Okay, now let me write this equation as it is. That is 3x square negative px positive q equals to 0. Actually, we have the quadratic equation in standard form. What is standard form? Let me write the stuff over here. That is ax square positive bx positive c equals to 0. Okay, whenever we have a quadratic equation in this form, that is ax square positive bx positive c equals to 0, and we will be able to get the sum of the two roots and product of the two roots using formulas. Let me write the formulas over here. So sum of the roots equals to, the formula is negative b over a. Without solving the quadratic equation, we'll be able to get the sum of the two roots using this formula, that is negative b over a, and also we'll be able to get the product of the roots, product of the two roots. Let me write the stuff over here. So product of the two roots equals to c over a. To get the sum of the roots negative b over a, what we have to do is first we have to take a negative sign and we have to divide the coefficient of x b by the coefficient of x square a. So this is a formula to get sum of the two roots. And to get the product of the roots, we have to divide the constant term c by the coefficient of x square a. That is c over a is a formula to get product of the roots. Okay, now let me use this formula over this quadratic equation. So already we know the two roots of this quadratic equation. They are 10th and 11th terms. That means 14 and 31 over 2. Okay, now to get the sum of the roots, what I have to do is I have to add the two roots 14 and 31 over 2, which is equal to negative b over a. But instead of, okay, first let me take the negative sign. Instead of b, we have negative p, which is a coefficient of x. Let me write over here. By for a, the coefficient of x square is 3. Let me write it. And also let's add the integer 14 and the fraction 31 over 2. Whenever I want to do addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take these two as a common denominator. Okay, when I multiply this 14 by 2, I'm getting 28. Then we get 28 positive 31 divided by 2. Equals to negative times negative will become positive, that is p over 3. Okay, when I add 28 and 31, I am getting 59 over 2 equals to p over 3. Okay, to solve for p in this equation, what I have to do is I have to get up the denominator 3 over here. For that, I have to multiply both sides of the equation by 3. So then 3 will cancel out. When I multiply this 3 and 59, I am getting 177 over 2 equals to p. Okay, now I got the value of p. The value of p is 177 over 2. Okay, now let me use the second formula, that is product of the roots equals to c over a on the quadratic equation over here. Already we got the two roots of this quadratic equation of 14 and 31 over 2. So to get the product of the roots, we have to multiply these two values. That is 14 times 31 over 2. Which is equal to c over a. In our quadratic equation, the constant term is q, so we can plug in q for c, and the value of a is a coefficient of x square, that is 3. Here 2 goes into 2 1 times and 2 goes into 14 7 times. When I multiply this 7 and 31, I am getting 217 equals to q over 3. Okay, now to solve for q in this equation, I have to get the denominator 3 over here. For that, I have to multiply both sides of the equation by 3. This 3 will cancel out. 3 times 217 is 650. 1 equals to q. Okay, I got the value of q as well. Now, using the values of p and q, we will be able to evaluate the value of the expression q negative 2p. Okay, let me do it. Q negative 2p equals to, okay, first let's plug in the value for q over here. That is 651 negative 2 times the value of p is 177 over 2. So we can plug in this 177 over 2 for p over here. That is 2 times 177 over 2. This 2 will cancel out. I am getting 651 negative 177. When I subtract 177 from 651, I am getting 474. Therefore, the value of the expression q negative 2p is 474. We find this 474 in answer choice B. The correct answer choice for this question is B, 474.